The subject of this presentation is neural graph reasoning, complex logical query answering meets graph databases. Not a coincidence, I guess, that the subject exactly matches a paper published in March of 2023 that discusses the research and proposes neural graph databases. It was republished in November of 2024 under the title Neural Graph Reasoning, a survey of complex query answering. Understanding neural graph databases as a combination of vector databases and graph databases with reasoning and embedding and complex queries handled in the database itself. This is a goal, by the way, not a product. Just a quick look, SparkQL from Apache and Cypher is used in Neo4j. These are examples of queries that will work on graphs. The proposal is to have a query planner, basically two sections to the engine, the query engine and the graph storage. The query executor embeds the query and does retrieval on embeddings in the store, which is created from the graph itself and from features. There are alternative approaches that try to use graph databases, and even the authors of this paper have a project called Ultra that's worth looking at. Here's our data, very simple, so we can follow what's going on. The first part of the code stores and loads a graph from to and from Neo4j. The second does embeddings with Word2Vec, Node2Vec. There are more sophisticated embeddings. And the third one uses BERT to embed a query and use GCN conv layers to predict the relevance. Using transformers and language models shows promise to generate embeddings, learn relationships for navigation, and generate explanations. We need to address missing links without hallucination and disjunctions and negation. In the near term, clever queries on graph databases may help, and even natural language prompts converting us to SparkQL or Cypher queries. Looking forward, we may have graph databases we may have graph neural databases. I recommend that you want to follow the researchers here.